Hello everyone, welcome to Mark 1 Design EMC video channel. In today's session, we're going to talk about how to set up a pre-compliance EMC test for mains powered product. The mains powered product can be home appliance or multimedia device and so on. To test the conducted emission of mains powered product, we need the setup showing here. We will go to details. Basically, you would need a mains listen, ground plane, and you also would need an isolation transformer. The reason that you need an isolation transformer is because of the way the listen is built, they have huge capacitance inside. When you switch on the listen, chances are that you will trip the RCD in the house. So you do need an isolation transformer to prevent the tripping from happening. Okay, so here shows you the test setup for a mains powered product. Now, it is a good idea to test any product against a benchmark result. So often we use a well-branded product which we know will definitely pass the EMC standard as a benchmark test. So in this case, we're using a well-branded hairdryer. As you can see, the test setup shows listen, ground plane, and we have some insulation material to support the DUT. And because the DUT is a handheld product, according to the standards, you will also need to have an artificial hand. Then on the product handle, we have we made some foil wrapped around to represent a hand holds the product. And here, of course, you would need a spectral analyzer to measure either the conducted noise on the line or on the neutral line, on the live line, on the neutral line. And first of all, I have to stress one important thing, which is high voltage safety. Now, lots of the videos I watched on YouTube talking about pre-compliance EMC testing, especially the mains powered product, they barely touch the high voltage safety, which in my opinion is not correct. So in this case, as you can see, for high voltage safety, you need to bond the listen front panel securely to the ground plane. Same applies on the rear panel of the listen, and using copper tape to tape it. And the listen itself is earthed to the isolation transformer casing, and the transformer itself is earthed. Okay, so make sure that the ground plane is properly earthed. This is for high voltage safety because any leakage current put on the ground plane can potentially damage yourself or kill yourself. Okay, so that's very important. Now we look at the listen front panel. This is a listen 16 amps 230 volts rated from Tekbox. On the front panel, we can see it's fairly straightforward. You have the 10 dB attenuator or a transient limiter. You can choose on or off. And here you can select to either measure the line voltage or the neutral voltage. Basically, the conducted noise can be measured from both line or either line. This is the RF output of the listen, which you are connected to your spectrum analyzer. The reason I didn't connect to the spectrum analyzer is because this output is, you need to check the output of the RF out of the listen. So first of all, you need to check whether the voltage level is within your spectrum analyzer RF input. Any voltage level higher than the specified input of the spectrum analyzer will damage the RF input or the RF front end of your spectrum analyzer. So be very careful about that. And the second thing is, even I measured the RF out of the listen in the idle state, that is within the limit, I'm not going to connect it until I run my product, simply because the product on the test can be highly inductive. So by the time you switch it on or switch it off, there might be a very big kickoff voltage, or often we call it back EMF induced, that can also damage the front panel or front RF input of the spectrum analyzer. So I will make sure that when I turn the device on, then I start measuring, and before I switch off the DUT, I will make sure that I disconnect the spectrum analyzer. So that's very important to note. Here you have the your mains power out connected to your DUT. Here we're using an artificial hand, because this product, as I said, is a hair dryer, and by testing standards, you will need you will need an artificial hand. So just to stress the points we just made, high voltage safety first, then always make sure that the spectrum analyzer RF input is well protected by checking the listen RF output, and also by disconnecting it in the right time. And for handheld mains products, if the standards require artificial hand, connect artificial hand. Okay, so now we are going to have the product tested. Okay, so everything set up. Switch on the listen. You can see the light is on, and we make sure artificial hand is connected, power cable connected, and we're going to measure the conducted emission on the live line. And then I turn the attenuator off because I already checked the RF output before I'm going to connect the spectrum analyzer. Okay, as I said, I need to switch on the product first. So turn on the product, and now I'm going to connect my spectrum analyzer. Okay, to start this conducted emission test of this product, I often use a software together with the spectrum analyzer. The software is EMCview, which is developed by Tekbox. There are many good reasons of using this software, which we will see during the demonstration. This software, I believe, is compatible with most of the spectrum analyzers from Rigel, Sigland, and Rorschach. And in my opinion, if you have already spent hundreds or thousands of dollars on a listen or temp cell or current probe, then it is worth perhaps spending a few $100s to get this software for the huge benefits that it could bring for your EMC pre-compliance testing. Okay, let's start the software. And as you can see, the user interface is quite neat in the sense that you have the main screen here and all the functions showing here. Let's just do a demonstration here. So the first thing is you need to connect to your device. So on the device, I collect device. Then because the spectrum analyzer I use is connected via USB, so connect USB, search, and then you can see I found the device, and then connect. You can also get your Visa version, which is showing here. Then you just close it. Then on the left bottom of the screen, you can see my Sigland SSA 3021 is being connected. Okay, so as I mentioned, this benchmark product is a handheld mains product. So we need to test the conducting emission to the correct standards. Now, the software itself comes with lots of standard limits and test preset files. So if I now collect file, then I want to load a project. Load project. So all projects are saved in a folder called source folder. As you can see on the screen, you have a wide selection of different testing standards. you have the automotive BMW testing standards, FCC 15, which is the standard they test in the United States, and you have the CISPA 11 to 35, all sorts. So for this product, I know the proper testing standards that it needs to be tested against is EN 55014. So I'm gonna click this one. So in the subfolder, you can see you have CN, RN, and TC, which stands for conducted emission tests, radiated emission test, and tensile test. Now, CISPA has defined limits for tensile tests, so that's quite straightforward. You can just load the project file and test using a tensile. For this test, I'm going to test the conducted emission using Listen, so click. And here again, you have lots of selections. And for this product, we will test EN 55014 household mains. So double click that. Okay, so the project is being loaded. So the limits is showing here. As you can see, the blue line is the quasi-peak limit for this product, and the red line is the average limit. Okay, and you can see the start frequency is 150 kilohertz and stopped at 30 megahertz. You can define a margin, which, you know, if you want to say, okay, I wanted to achieve a margin of 10 dB or 5 dB, you can put in here. So in this case, we put, let's say, 6 dB margin. And it gives you 6 dB margin just for the average value. And of course, you can put the same margin on the average. And you can see the blue dashed line as the margin value for quasi-peak. Here is the cable characteristics, RF characteristics. So you can select your cable, which is often tiny, but let's just put it in this case. So in this case, I'm using N-type to BNC type, 75 centimeter long RG223 cable. So click that. And for the Listen, it is a Tekbox model, which is Tekbox TBL 50162. And now, even with this model, you can have the attenuator off and on options. So this we already explained before. So when you have attenuator on, of course, you protect the RF input of your spectral analyzer, but often for pre-compliance tests, I tend to turn the attenuator off. But of course, before that, I always make sure that the measure the value not exceeding the maximum input of the RF input. So in this case, I'm selecting 5016-2, which is the Listen model, and with the attenuator off. Okay. The next is the amplifier or attenuator ratio, which you can select 10 dB, 20 dB, or any values you want. You can also define your own in the log file. Then it is the antenna RF characteristics. So in this case, they have some Tekbox antennas here, because in this case, we're not using antenna for radiated emission test, so just put none. Moving towards the segment setup. Now, one of the reasons I use this software is because it does the segment scan automatically and then basically stitch all the segments together and then giving the plot on the picture showing here. If I hadn't had this software, that means I will need to do the scan manually by myself using the spectral analyzer, and then I need to find a way of stitching each segment together. You might ask, oh, why do you need to scan it by segment? Well, that is a good question. Most of the spectrum analyzers sweep the frequency range in discrete steps. Typically, the number of frequency steps per sweep is identical with the number of display pixels in the x direction. For instance, the Siglent SSA3021 model that I have has a resolution of 751 frequency points per sweep, while I think most of the Rigel ones, I believe they have about 600 measurement points per sweep. Spectrum analyzers usually power up with the sweep set to full span and resolution bandwidth set to 1 megahertz. When you measure some signals, sometimes you will find that the amplitude or the frequency point is not displayed correctly. This is due to the fact that if we look at the filter curves and the spacing between adjacent frequency points, you will see that if I divide 2.1 gigahertz by 751 frequency points, this will result roughly 2.8 megahertz. Yeah, so there's a big difference between 2.8 megahertz and 1 megahertz. Let's take another example. We look at the conducted emission test we're going to do. In most cases, this frequencies sweep starts from 150 kilohertz up to 30 megahertz and has a resolution bandwidth of 9 kilohertz. These are all defined by CISPA. If we want to make a full sweep across the entire 30 megahertz, that means we can do the math. 30 megahertz divided by 751 points, that gives us 39.9 kilohertz. And compared again with the resolution bandwidth 9 kilohertz, surely you will miss lots of useful information. So in order to cover the entire frequency spectrum, CISPA 16 actually defines the adjacent frequency points shall not be more than half of the resolution bandwidth. So in this case, again, 9 kilohertz divided by 2 should be 4.5 kilohertz. So with this information and the as long as we understand the our spectrum analyzer model correctly, we can do the math, and it shows in this table based on the model that I have, which means that for the conducted emission test we're going to do from 150 kilohertz to 30 megahertz, we will need to split the entire spectrum into at least 9 segments with a span of 3.38 megahertz. Now, you can of course do this test manually. So basically you start the frequency range at certain point, and then you only scan for a range of 3.38 megahertz, and then you start the next segment again, saving all the data in the spectrum analyzer in data points, and then you extract those data, and then you can do some post-analysis, which is fine. But by having a software that can do it for you automatically within 5 or 6 minutes, really saves huge amount of time and effort. That's why I tend to use software when it comes to EMC pre-compliance testing such as this. We have segment set 1 and segment set 2. And the set 1 is going to do a scan based on the average scan. And the segment set 2 is based on the peak scan. Okay, and you can see set 1 is now selected. So if I click start now, the software basically will tell the spectrum analyzer to start an average scan. Once that is done, I then can select set 2 and then start it again, and the result will show here as well with the peak scan. Okay, and so that's the most important parameters to set for this test. So we set it just as it is. Okay, and put it back to set 1. And what else we need to do? I think, yeah, for a quick scan, that's probably enough. It's worth mentioning that you can save this project, right? So with all this test set up, I already defined, I can save the project. Yeah, the default folder is still within the source folder, so I would suggest you keep in that location. So I put in source, and I can just give a name. So in this case, I can call it pre-compliance test 1. Okay, so then I'll save it. So next time I can just load project, which is already saved here, and I don't need to change all these settings. Okay, so now with all this set up and connected properly to my spectrum analyzer, the next thing I need to do is click start. Okay, so now we're gonna click start, and as you can see, the software basically sends commands to my spectrum analyzer. The scanning started now. All the resolution bandwidth, video bandwidth, and stop and start frequency has been predefined, as I said, in the segment file. So you can see here we're doing a frequency step of 235 kilohertz scan. So that's the first segment scanning finished. Now we're starting from 3.75 megahertz. We're starting from 2.5 megahertz and now stop at 5 megahertz. Yeah, so you can see all the values are predefined in the setup file in EMCview. So very easy. We just wait until the scan of each segment is finished. All this data will be transferred back to the software, and the software will automatically stitch all the segments scanning results together and put the results on the output file. So let's just have a look. So yeah, the first segment data is now stored back into the PC. As you can see from the screen, we have average scanning results showing here, and currently it is still below the margin line, which is pretty good. The first scan also starts from 150 kilohertz to 2.5 megahertz, and as we just speak, the next scan, the segment data will be now put in again. And here also you can see the estimated remaining time, which is estimated at 6 minutes left. So it's pretty easy. As I said, you just wait for 6 minutes. In the meantime, you can get yourself a cup of tea and just wait until the results are finished. Okay, so after a few minutes, both scanning for average and peak scanning are now completed, and we have the results showing in the software interface. And you can already see that I have labeled these limits correctly, and I can also label these two traces which are just plotted. Right, doing that is fairly easy. You just need to go to labels, yeah, and then set label. Then here there's a new label. Then you can drag easily, and then right click, and then you can edit. So basically here we know the purple line is peak value, so I can just say PK, yeah, and then you can do the same for the average. Okay, so we can see here in this case the plotted results are all under the limit, and also even within the margin we predefined, which is pretty good, which shows this product surely will pass conducting emission scanning. So there are a lot more functions within the capability of this software, which we can't cover everything in one session. Some useful features are found very high efficient. For instance, if you don't want to do a full scan from 150 kilohertz to 30 megahertz, what you can do is you can select segments here, and you can see you can drag each segment into different position, and you can, by selecting all or specific segment, then you just do a very short quick scan and to just focus on that area. So that's one function I highly recommend. Other useful functions include you can also use this software as a generator to generate your spectrum analyzer's tracking generator connected to an RF amplifier to do some immunity tests. One other useful function is if you go to File and then you go to Utilities, you can save the results as pictures, as CSV file, or what I found most useful is you save charts. So by clicking Save Charts, you basically save all the raw data in your computer. And one of the benefits is, of course, we just did this scan for this benchmark testing. We save this chart, and then we can do another scan of another product. Perhaps it's a product from your customer that asks you to look at, and then you can basically compare the performance of that product with these benchmark results. So in this session, we demonstrated step by step how to set up a pre-compliance conducted emission test by using a LISM module, a spectrum analyzer, and an EMCview software. We explained why it is important to always make sure that high voltage safety practice is executed first. We then explained why it is important to do the scanning segment by segment. If you have the software, of course, the software will do it for you very easily. If you don't have the software, I would also suggest you do it segment by segment and perhaps using some other software to stitch the segment together later on. We used a well-branded, good quality product for benchmark testing, and the results show the conducted emission is within the limit. So this often serves as a benchmark testing. And then when you have other product to test, you can always use this result as a benchmark, as a reference. I hope you enjoy this video, and if you like it, please share with your colleagues. And also if you like it, please subscribe to our channel and also visit our website for more information. Thank you very much.